Hello again, this is Kevin Patton for Gallagher Fluid Seals. Today we are going to discuss rotary sealing failure modes. Seals play a critical role in ensuring rotary systems function properly. These types of systems include transmissions, gearboxes, pumps, motors, and other rotating equipment. Many factors can affect seal performance, but reducing the most common problems can help seals function at their maximum potential and life. As a system designer, plant worker, or equipment manager, you may not be aware of just how many factors can affect performance. Rotary seals are more complex than a standard O-ring. They may have a spring that matches the seal material. They may have additional features to reduce contamination, and typically the range of standard designs is more robust due to more sealable applications. Today we will look at each failure mode in detail. Through understanding the importance of proper installation, contamination control, friction, mating surface conditions, shaft dynamics, and fluid conditions, this video guide is designed to help reduce the risk of errors in rotary seal applications. The first rotary sealing failure mode we will discuss is installation. The purpose of a seal lip on an oil seal is to ensure seal wear is low. The correct amount of lubricant surrounding the lip helps keep friction and wear minimal without a resulting leak. 2022's robust and sophisticated seal lips are typically designed to do just that. But this type of added functionality does make installation a bit more complicated. Whether comprised of rubber or PTFE, which most seal lips are, they tend to be delicate or fragile. For difficult installations where the geometry is tough to maneuver, the lip may be damaged or turn the complete opposite way, or inside out during the installation process. Due to the seal lips being small in most cases, they can be easily installed backwards by an inexperienced installer, which will ultimately push fluid in the incorrect direction. But fortunately, these two problems can be avoided or solved by following simple guidelines during oil seal installations. Ensure that seals do not go into equipment at an angle, and do your best to make sure that favorable conditions exist during the seal installation to avoid damaging the lip. Something to note, which not everyone does, including some of our own customers, if you are able to, briefly stop and check the seal during the installation process. Ask yourself, is it the right oil seal? Is it the right size? Is it facing the right direction? Is it installed in the correct way so that the rotation of the shaft corresponds with any pumping features of the seal? Next, we are going to talk about the second failure mode of rotary seals, contamination. In rotary systems, it's common to have a seal near a ball bearing or other rotary bearing. It's natural for various debris in the system to move towards the bearing. This causes further debris to loosen and part from the bearing, ultimately damaging the seal. You might think that changing system fluid would help with the issue, but changing it won't necessarily fix your problem. This is due to the bearing acting as a deterrent to the flushing of the contaminant. This actually tends to lay near the seal. In order to reduce seal failure due to system contamination, here are things to consider. Before assembling anything, ensure system elements are fully cleaned. This will help you start off the right way to avoid any issues from the onset. If something was just machined, pay attention to debris from the machining process. It's important to inspect and conduct checks on your system oil frequently. This will help determine any level of elevated contamination. If it's high, you should flush the system. If you are replacing a bearing in your rotary pump, you should replace the seal as well. It could have been exposed to external contaminants during the bearing replacement. This would make it extra susceptible to failure. Up next, we will discuss friction as a rotary sealing failure mode. Rotary systems produce heat that is different when compared to linear systems. It dissipates in a unique way. This means that the shaft surface and area surrounding the seal may experience higher temperatures than those in a static application. What this can ultimately lead to is damaged shaft material or degraded seal lips. To fix this, there may be a variety of solutions. Sometimes changing materials will help. If you're using a rubber seal and there's a lot of friction, you may need to switch to a PTFE material or some elastomer with higher temperature resistance. Or even changing the viscosity of the fluid you're using to a higher viscosity may help. Considering fluid flow into the equation could also address friction failure modes. Placing more lubricant into your system between the seal and the shaft can help reduce temperature. The next failure mode we are going to discuss is mating surfaces. Shaft finishing processes are essential. When installing your seals, there should be no sharp edges or particularly rough edges, also known as burrs. Either of these could damage the seal upon installation. Second, unless precautions are taken, a microscopic screw pattern can be embedded into the shaft finish, creating a micro pump that inadvertently directs fluid. The solution is to use plunge grinding rather than traditional grinding and ensure that there is no angle to the machining marks. As always, it's important to consider the surface finish of the shaft. It should be matched to the seal type as well as material to ensure there are no future issues. For example, a finish that is too rough will cause the seal to wear quickly, while a finish that is too fine will not allow lubricant to be retained under the lip, resulting in higher friction. For additional information about surface finish, refer to the Gallagher Fluid Seal Surface Finish video series on YouTube or find the videos on our website www.gallagherseals.com. Next, we will discuss shaft dynamics. Seal function can be affected negatively by misaligned shaft movement. Think about a worn-down bearing or low-quality bearing. It may allow the shaft to shift, ultimately putting wear on the seal prematurely. Similarly, if your shaft is not properly installed and has misalignment, certain seals may become more compressed than others in the equipment. And as you are aware, compressed sections will wear more quickly, whereas the uncompressed seals may have issues with leakage. The solution to this problem really starts at the beginning, with the design of the equipment and seal. The finished product, the shaft, equipment, accessories, and seals should line up exactly as they are intended to. Secondly, utilizing a bearing from a high-quality manufacturer with precise machining certainly helps seals to operate as intended. And the final failure mode we are going to discuss today is the condition of the fluid within the equipment. Due to the nature of assembly, seals are tucked behind bearings in a rotary system. Because of this, there is a minimal amount of fluid interaction. It's important to check fluid conditions on a regular basis for a number of reasons. If there is excessive air in the system, it can cause air bubbles around seals. If there is high moisture content around the pump, it can cause an imbalance of water content or water level in the fluid, leading to issues. And of course, you'll want to check the oil level, because it's very common for seal failure if oil levels are low. If fluid conditions are not ideal or optimized, bearings may wear prematurely. This can cause a host of issues, including misalignment with the shaft, which then can allow debris into the system, ultimately damaging the seal. That's why it's important to regularly check the condition of fluids within your equipment. Thanks for tuning in to our rotary seal failure mode video today. If you are experiencing seal failure in your rotary system or feel like you could benefit from a better designed seal, contact Gallagher Fluid Seals via our website and we'll be happy to assist. Thank you.